Save time and money. Make fewer decisions. To start off this extensive topic, we first need to answer some basic questions. Which parts or assemblies can be designed modularly at all? A tip: there are more than you think. Can it be flexible despite its modular structure? What are the savings? And how is it realized in practice? And with that, welcome to LearnNX, the free learning platform for Siemens NX. Well, the first three questions can be answered independently of a CAD system. Only when it comes to practical realization, it will, of course, be explained using NX in this channel. But let's start with the question that is typically asked first. What are the resulting savings? Let us imagine the following task. A bolt is to be constructed whose task is to lift parts with a low weight by a few millimeters. The task is clear and simple, and yet it requires an incredible number of decisions. What is the diameter of the shaft? What is the diameter of the collar? What is the shaft length? How thick is the collar? We have free choice for all of these parameters. On top of this comes the choice of material and heat treatment. As a result, an individual product is defined for this standard requirement. We must avoid that. Standard requirements must be met with standard products. In this case, for example, it would be possible to rasterize the selectable sizes without any loss of quality. In order to really meet all customer requirements, no standardization is implemented. Yet there are many bestsellers that are only offered in a coarse grid. Take paper, for example. The DIN A4 paper format is followed by DIN A3, which is exactly twice as large. Despite this really extreme rasterization, no intermediate sizes are offered. There is obviously no demand. Or screws, for example. Regardless of whether we look at screws in inches or millimeters, the diameters and lengths are rasterized. Otherwise, no exchange would be possible. Anything else? T-beams, steel tubes, bicycle tires, all rasterized bestsellers.
But you can't compare simple things like T-beams, steel tubes or bicycle tires with complex special machines, beautiful houses or functional punching dies.
Yes, you can, because the boundaries of parametric CAD systems have shifted. You can do more than just change the size of variables. This brings us to the second question. What is modular design? Or, which parts are suitable for rasterizing at all? Certainly the spring bolt described, but hardly these parts. Or, are they? At first glance, the parts seem completely different, but let's try not to see them as a whole, but as a modular system. What do all the parts have in common? What do their recurring modules look like? All parts have two contours, one defines the outer contour of the flange, and the other the contour of the wall. In addition, all parts have two faces, one for the flange, and the other for the floor. So, all parts are defined using these four recurring elements. Once you have analyzed the modules, or rules, they are already replaceable. This means that elements can be exchanged, and components and machines in the background adapt to the changes.
But this is a prepared presentation with a few tricks up its sleeve, right?
Of course there are necessary preparations. But this channel is not called Magic NX, it's called LearnNX, and you will get to know the methodology. So, modules can not only be geometries, but also repetitive work steps. Modular assemblies. Here too, once the rules have been analyzed or, even better, defined in advance, it is possible to exchange the modules. In this example, the rule is, if an element with a variational width or thickness is replaced, the other elements must be moved accordingly. This is how walls of houses could be created, or punching dies. This gives us the answer to the question, what is modular design? The modular design follows an analyzed structure, or, even better, predefined rules. And this brings us back to the starting point. What are the savings? Decisions cost time and resources. Rasterization not only leads to faster development, but also to lower production costs, as the fuse sizes can now be manufactured in higher quantities. The effect extends to warehousing costs, administrative costs, and even a simplified ordering process. The number of decisions must be reduced to a necessary minimum. This can be done on many different levels, for example, by rasterizing the components with the help of part families. With this command, the parameters of a master part can be linked to a spreadsheet. Each line of the spreadsheet creates a part or an assembly. Parameters can be changed here. Work steps can be switched on and off. And also components can be replaced. This allows you to quickly create your standard parts and assemblies, which can be conveniently made available to your colleagues in a library, which are then installed in a predefined manner. Even the required installation space can be generated automatically. Prepared in this way, parts and assemblies, including the installation space, can be replaced quickly and easily. And necessary changes can be made centrally, for all parts, via the master part. So, there are a lot of predefined decisions in these part families. Of course, the resulting parts can also be individually adapted at a later stage, and still remain connected to the master part. Feature template. But there are also ways to minimize the number of decisions within a part. Recurring details on components can be inserted, changed and manufactured more quickly using specially created tools. Material can be added or removed with these modular, geometric components. And this is how special holes, gear wheels or such slots are created. And, of course, can be changed at any time. Can you do more? Yes, with the help of the model-based definition you can also create dimensions using predefined rules. For example, all holes are given a predefined position tolerance. Of course, the surfaces can also be colored, as is common in toolmaking. Central development of parts and assemblies. Nothing is so good that it cannot be improved, but sometimes, errors in parts and assemblies simply have to be eliminated. And so parts and assemblies are subject to constant change, you could almost say evolution. This results in more and more variants of the first assembly. Only by categorizing the problems, and the associated standardization of solutions, is it possible to develop and maintain the variants centrally. Sharpen your focus with us, and learn to view parts, assemblies, and work steps in a modular way, in order to minimize decisions, and thus save time and costs.
Doesn't creativity fall by the wayside here?
No, because it takes a lot of creativity to discover the modules in everything. Think how much creativity must have been needed to develop the periodic table. And today we use it as a matter of course. So discover your periodic table in your modeling. The topic of modular design is taught over several consecutive courses. Interested? Then support us and subscribe to the channel to never miss a new video.